just like on the lesson, it just starts off with x equals or y equals a number. It doesn't matter because we're not graphing. It doesn't matter that it's x equals or anything because we're not graphing. But then they'll turn into, okay, just 5x, 2y, something a little bit more, and then we'll have full expressions. Okay? So let's do a few of each of these to start us off. Notice how each of these, you have to write the solution down here, and then do a check as well. So here we go. Look at number 2. So y equals -1, right? So that means this y is also equal to -1. So I'm going to put this equation, -2x plus 3 times -1. That's going to equal 9. And then from here on, it's just solving the equation. So 3 times -1 is times 3, is 9. And just be organized and neat so we don't miss a negative or something small. Okay. 0. So bring down the -2x. 9 plus 3 is 12. And divide by -2. -2 divided by -2 is positive 1, so we have 1x equals 12 divided by -2, which is -6. So we're not finished yet, though. We've only found x, and we're looking for x and y. So if you've got here in the solution, you can put -6. Right? However, if you go back to the beginning, this is a unique situation. We know that already that the answer is -1 because we have y equals -1. If you look at the other problems, it's not that simple. We'll do those in a second. But we know from the beginning that y is -1. And now we use this other equation right here for our check. So we're going to plug in our answer. Right now, this is a question mark. Is it the solution? Not for sure. So go ahead and plug in your x, -6. Plug in your y, still -1. And we're trying to verify whether or not it's actually equal to 9. If it is, we're done. If it's not, we need a mistake. 12 -3. So looks like, yes, same thing on both sides. So we have an answer. This is so after here, you'll see it'll be a little more involved, but still very doable. So the nice thing about everything tonight is that we're always going to have an x equals or y equals ready for you, or a b equals or c equals, whatever the variable is. So x equals 4y. So that means this x also equals 4y. So let's set this up. So I have 2 4y. Right? And then the rest is plus 3y equals 44. And then we just have to solve this. At this point, after you substitute, you should always have one variable. We have an x and a y still, something's wrong. So we have here 2 times 4y is 8y. Right. 8y plus 3y. And divide both sides. 44 divided by 11 is 4. So down here, put a 4. Okay. Is that right? Any mistakes there?
Yeah.
Where? Yeah. So this is one of those things that'll drive you crazy. That you do all this work and then you forget, wait a minute, I found y, I didn't find it. So the first variable you solve for doesn't mean it's first in your answer. It's always alphabetical. Especially when you have other letters like C and D down below on number 7, make sure you write them alphabetically. Don't do, if you find D equals first, don't put it first. Okay? So now 4. Now, unlike before, we don't have just x equals an answer up top, but we do have this formula. So we see that x equals 4y, right? But now we know y equals 4. Right? So we can take 4, substitute it right here. So y equals 16. And the bigger these numbers get, the more inconvenient would it be to graph. Like, imagine this if this came out like 56 or something, like this big. We're trying to graph it. It's very difficult. So it reinforces the reason for doing this method. It's because big numbers or decimals and fractions, not nice to play with. For your check, notice how I use the top one to find out what y equals or what x equals. So I'm going to use the other one for my check. I'm going to use one of these to find out the other variable. Use the other one for your check. So 2x plus 3y is 44. X is 16. Y is 4. 2 times 16, 2x. Plus 3 times y, 4. Does it equal 44? That's the question. If yes, then we got the right answer. If no, we made a mistake. So 16 times 2 is 2. 3 times 4 is 12. And yes, 44 equals 44. As long as you do a true statement, you're okay. Down below, so it looks like if you look at the structure of number 3, how it has x equals 4y, it looks like 4 and 5 are basically the same thing. So 4 is 5x, y equals 5x, 5 is x equals 2y, more or less the same. Here you can see how they're both y and slope-intercept form. We could graph these and see where they intersect, but if we wanted to solve these algebraically, it'd be a lot like number 1 on last night's homework. But this y is the same as this y. So here, we're going to plug it in over here. You just plug in 2x plus 3 on the left-hand side. 2x plus 3 equals 4x plus 1. More or less, you're just setting these two equal to one another, like we did before. So it's a different type of equation. We have variables on both sides, and we have to solve that in the same way. When you get to, and that's very similar to, I think, like these, how they're, both of those above were y equals, both of these are x equals, but the idea is the same. This x is the same as this x, so I can plug it in over here. 2y minus 3 equals 2y plus 4, and so on. Last one I want to go over is number 7, where you have to plug in and distribute. Notice how these are C and D. So make sure your solution down below here is C, comma, D alphabetically. Okay. C, comma, D alphabetically. So we have C is going to be 1 less than D, which is right here. That's D. Oh, sorry, we need to plug in D. So we have 4. And then the D minus 1, which is what C equals. D is D minus 1, so put it in D minus 1 there. And we have to do this little distribution. So you can see the steps are basically the same problem to problem, but there are differences. I can't tell you one set of concrete steps that works for every problem. Sometimes you have to distribute. Sometimes you have variables on both sides. Other times you don't. You just have to be familiar with all the different types of equations and do the right steps for that particular problem. Good example is like when you guys are learning to drive, depending on the weather conditions, might change how you get into the car and start it. Okay? Yeah, you have to do a lot of the same things, but depending if it's raining, you turn on the defrost so the windows don't fog up. But if it's sunny, you put down the window. I'm leaving it up to you guys at this point to know, well, when should you do each of those? When should you be distributing? When do you have to subtract on both sides? It depends on the equation. It's not like I can tell you, here's how you do all of them every single time. Just rely on the information, okay? And it'll become intuitive to the point where you're not even thinking about it. Like when you guys start driving, the instructor will get in the car with you and tell you, okay, go down to San Antonio, make a right, and you'll get in the car and do everything and just go ahead and do it. But you're not going to be thinking, okay, first I have to unlock the car, then I have to open the door, then I have to get in the car, then I have to close the door, then I have to put the key in, then I have to turn the key. You're not going to be thinking about all these little tiny steps, right? You're just going to know what to do. That's kind of like here. You have to just know, like, well, we're not going to talk about every little step, but you're familiar with that by now. Okay, if not, that's why we have, all the tutoring before, after school, and on the weekends and all this stuff. So if there are gaps and pieces missing, just make sure you come in so you get help with that. Okay?
Is it possible to have no solution?
Is it possible to have no solution? Absolutely. Okay. Good question. So how do you know if it's no solution? Yeah. So when you get to this point, how can I make this a no solution?
If you want to make either that 4D or the other side 3D.
Yeah. If I made that a 4, right, and I subtracted 4D on both sides, it's just an example. Don't copy this down. Then it would cancel on both sides. I'd have -4 equals 3, which is false, so no solution. And you can also have all reals. So if it was 3 equals 3, it would be all reals. So the same rules as before. That's kind of what I was just mentioning about the, you're not told to open the door, get inside the car, close the door. You just kind of get in the car. So these are things that we've already done, we already know. Just assume that everything we've learned up to this point is still important. So you can still get no solutions, still get all reals, all the same rules apply. Okay? Good questions, yeah. More? All right.